Trethwest is a multimedia startup company specializing in mobile games, music production, graphic arts, and general creativity. Bring the beat in. Today we're going to be doing a game development module. The purpose of this is to introduce you to 2D mobile game programming and content creation. Specifically, we will be looking into coding, graphics, and audio production. We will also be touching on the collaborative process, what it is like working with a team to do this, and also expose you to some of the tools that are at your disposal. We generally want to show you what is possible with the programs that are free to use and are open to anybody. We are going to do this through the context of an app that we are creating and the software we use to make it. This is not a step-by-step guide on how to create a mobile game. We wouldn't be able to do that within a single video. Further, this is not an easy process. No one jumps in and becomes an expert game programmer, music producer, or graphics artist overnight. But if you put the time in and the effort, it is a very rewarding process. The goal is to have everything you create be better than the last thing you made. Everything you see here was made with the tools that we are about to show you. With that in mind, the purpose of this video is not a long drawn-out tutorial. Instead, we want to share with you a little about our story and show you what is possible and hopefully inspire you. So why do this? Why do we do this? And why are we encouraging you to do it? Because it's dope and we think you'll get a lot out of it. It'll make you smarter, give you something productive to do. And we selfishly want you to be the talent we hire in the future. The people who create can open a lot of opportunities for themselves. And remember, anything you learn doing this is transferable to future jobs, academia, and so on. Back in the day, to do what you can do now, you'd have to have a computer that would have cost you over $5,000 in today's money. You no longer need to have access to the expensive teachers in schools to learn how to code. With the advent of the internet, there are lessons everywhere. Our story starts off in the beautiful southern Vietnamese city of Rhet Ya. For years, music was all we focused our creative energies into. In Vietnam, we were thinking out loud about where our creative efforts may take us if we repurposed the skills learned during our years of doing hip-hop production. Our quizzical musings took us to the inspired world of 2D gaming for mobile phones. At the time we were playing mobile games, we thought to ourselves, maybe we should make music for games. Then we thought, why can't we make the whole game? Initially, we came into this with zero monies, one laptop, and a cracked Android phone. We were a two-person team with a do-it-yourself attitude. And that's kind of the point of this video. We want to show you what we do and get you inspired to think that you can do it too. So how did we get started? As you've seen in the intro, we are currently working towards a release of a game called Me in a Box for both Android and iOS. Me in a Box is about a protagonist who is stuck in a box and is trying to get out with the help of a player. But long before the realization of Me in a Box, we started first by demoing various game concepts in a programming language called Python, using a game library called Pygame. The Python programming language is freely available and widely used, so there was a lot of help online to learn it. Pygame is a Python library intended for writing video games. Pygame allows you to draw graphics to the screen and play music and sound, and as well access keyboard and joystick inputs. There are great tutorials teaching Pygame to beginners. Pygame let us build our first physics game engine and allowed us to test rudimentary environments so we could see our initial game concepts come to life. It allowed us to demo our first graphics and just generally get familiar with programming for our first game. It is extremely easy to learn, so it's a great place for beginners to start learning programming and game programming concepts. When we felt confident enough in our programming, that is when we decided to move it to a mobile game platform. we had to decide what platform we would target and what tools we would use. Initially, we chose to target Android because we mainly had PC computers to work with. However, we always wanted the ability to port the game to iOS down the road. We were looking for a game library that was fast, 2D focused, worked with Android and iOS, had a built-in physics library, but not a complete game engine, and could be used freely in commercial products. If you're just starting out, two great engines that can be used for this are Godot and Unity. We particularly recommend Godot for beginners. However, for us, we were looking for a low-level library that didn't have a built-in game engine that would allow us to customize the physics and gameplay to our concepts. Therefore, we chose upon a game library called libgdx. We acknowledge libgdx is not the easiest or most beginner-friendly game library. It doesn't provide a nice point-and-click interface that organizes all your game assets such as music and graphics files. libgdx requires the user to learn Java, the native Android programming language, which can be challenging for some. But for us, libgdx provided us a blank canvas that was fast, free, powerful, and allowed us to build our own game engine from scratch. Now that's not easy, but we felt up to the challenge. So let's look at a libgdx program and Android programming in general to give a sense of the environment we worked in. First, please note that your computer should have both Android Studio and Java installed. libgdx can be freely downloaded from its creators, Bad Logic Games website, libgdx.badlogicgames.com. At the top of the site, we can go to the Download tab and then download the libgdx setup app. When you run the app, you are greeted with the libgdx project setup tool. This will create a skeleton Android program that incorporates the libgdx libraries. To start, let's give our project a name. We'll call our sample game My First Game. Next, we must give our game a Java package name. This usually takes the form of com.yourorganizationName.yourappName. So for us, we'll use the package name com.trethwest.myfirstgame. And for the game class, again, we'll call it My First Game. Next, we need to select the game's destination folder. We will create a folder on our desktop called My First Game. Then we need to provide libgdx the location of the Android software development kit. The links for both Windows and Mac are found below. You'll need to replace the username with your computer's username. Finally, under subprojects, you can select all the platforms you want your game to run on. For this example, we'll just include desktop and Android. When you're ready, you can click Generate to create your skeleton game project. Once the setup app is done creating your project, open Android Studio. You can open an existing project and open the project that was created on your desktop. When it's done loading, you'll be looking at your first Android project. So let's get you a little comfortable with Android Studio. On the left side are all the project folders that contain your source code files and game assets. Game assets refers to all your graphics, music and sound effects files, fonts, and whatever else you require for your game. Since libgdx is primarily an Android library, all your game assets are stored in the Android assets folder. When you load your libgdx application for the first time, there will be a single image called badlogic.jpg in your assets folder. You'll also see a folder for each additional platform you included in your setup. These folders contain the files necessary to launch your app on these platforms. Since we only included a desktop platform, we'll only have a desktop folder included in addition to our Android folder. Finally, you'll have a core folder. This folder contains all your project source code. By default, Android Studio will want to run your app on an Android device or within a simulator. This can be a slow process waiting for your code to load your phone or tablet. Luckily, libgdx allows you to execute your code directly on the desktop so you can test your code more easily. To set this up, in the top bar, click Add or Edit Configurations. Then click the plus symbol in the top left corner of the window. We will add New Application Configuration and call it Desktop. For the main class, select Desktop Launcher. For the working folder, we need to select the folder that will contain all your game assets. So let's browse and select your Android, then Assets folder. Finally, for the use class path of module, we will select your game's desktop.module. When you're ready, click Apply and OK. Now you can click the Run button in the top bar and your program will now run directly on your desktop. And this is it, a simple skeleton libgdx program. So let's navigate to the core folder to find your game package and source code. Double-clicking on My First Game opens up the Java file that will contain your code. Before we specifically look at libgdx, let's talk about a game loop. Most games typically have a structure that follows what is called a game loop. A game loop will often look something like this. The game first checks for any user inputs and responds to inputs from the user. This could be taps on the screen or game button presses, which might move the user's character or causes it to jump. Next, the artificial intelligence for the game's enemies will be run. This could include making an enemy move back and forth or attack the user's character. Next, the positions of all the game pieces are moved, whether they are users, characters, or the enemies within the game world. Next, determine if any of the game pieces have collided and react accordingly. For example, if the player's character hit an enemy, the player might lose some health. Next, once all the game pieces have been updated, we can draw all the graphics to the screen. And finally, if there's sound effects or background music, these can be played. Then repeat. This loop will repeat extremely fast. libgdx will repeat this loop 60 times for every 1 second. With the game loop in mind, let's look at the structure of the libgdx project source code. The code is initially broken into 3 functions: create, render, and dispose. The create function is run every single time your game is loaded for the first time. This is where you load all your game assets like graphics and sound into the system memory. The dispose function does the opposite. Every time your game is closed, you dispose or remove your assets from memory. And finally, the render function is your actual game loop. Everything within your render function will be executing over and over again. So this is where your game logic will be placed. To get a feel for how this environment actually works, let's use libgdx to display a graphic to the screen and move it around. All graphics in libgdx are loaded into objects called textures. By default, your libgdx program will load the badlogic.jpg file into a texture object called img. These textures can then be displayed on the screen using an object called a sprite batch. By default, you're given a sprite batch called batch. To draw it to the screen, you must first load all your images into a batch. You do this by beginning the batch through the batch.begin function. You can draw everything you need to this batch. In this case, the texture img is loaded into the batch at coordinates 0, 0, or at the bottom left of the screen. When you're ready to draw the batch to the screen, you can execute the batch.end function. The first two lines in the render function will paint the background red. We can change the background color by adjusting the red, green, and blue values from 0 to 1. We can adjust the image's display location by changing its X, Y variables. Let's set the X position to 100 and Y position to 50. Now the image has moved up and to the right. So it's still image on the screen. Kinda boring, right? Let's move it. Let's declare two new integer variables, X and Y, that will represent the position of the image on the screen in our create function. We'll initially set them to 0. Now we change the location where the image is drawn to X and Y variables. Now remember, the render function is called 60 times every second. So for every loop, let's add 1 to the X variable and rerun the program. Now the image moves across the screen. But this will just keep moving the image to the right forever. So let's put in conditions that will bring the image back to 0 if it goes too far to the right. If the X position of the image goes past, say, 300, let's bring it back to 0. Now when the image reaches 300 units to the right, it restarts. Alright, kinda cool. But let's make this a little more complicated. Instead of incrementing the image by 1 unit to the right, let's see if we can go in both directions. I'll create a new variable called delta X. And for now, let's set it to 1. This will represent how much to move the image by every game loop. Now instead of incrementing X by 1, let's increment it by delta X. And now, let's make our stop increment a little more complicated. If our delta X is positive, the image will move to the right. If our delta X is negative, the image will move to the left. So let's try to make the image reverse direction if we went too far. If it's positive, then we can check if the image X position is greater than our stop position of 300. If delta X is negative, which means it's going left, then check to see if image X position is less than 0. If it is, we can reverse the direction by multiplying delta X by -1. Now when we run the program, the image goes back and forth. In this way, we can begin moving images on the screen. Let's do something even better. Let's animate the image. Here's an animation of a character we created in a sprite sheet that contains 4 frame images. We'll store the sprite sheet file in our Android Assets folder as a file called creature.png. We'll then load creature.png into the texture called img. Now when we run the program, the bad logic label is replaced with our creature. Notice, it loaded all the frames side by side, just how they are in the image file. Let's cut them down. Now, here's where we need to know the sprite's dimension. For this sprite sheet, each sprite image is comprised of square images that are 256 by 256 pixels in dimension. So the entire sprite sheet is 1024 wide by 256 pixels high. Knowing this, we can create a new object called the texture region. Which we can load only a portion of the sprite into. Let's just load the first frame into the texture region. The first sprite is located at 0, 0, and is 256 pixels wide and 256 pixels high. Now the texture region we just created contains only the first sprite. If we draw the texture region to the batch, we can now see that the character is only shown one time. So how do we load the other frames into texture regions and then animate them? For this, we create an array of texture regions of 4 textures to match our sprite sheet. load each subsequent frame into the next texture region. Remember, each frame is 256 pixels wide, so the second frame will start on the 256 pixel. The third frame will start on the 512 pixel. The fourth frame will start on the 768th pixel. Also, in programming, we always start at 0, not 1. So the first frame will be the 0th object, the second frame will be the first object, and so on. Now we can display any of the frames we want onto the screen. Let's display the third frame. Okay, cool. But let's animate it now. To animate it, we'll need to keep track of the time in the game, so we can know when to switch frames. To do this, let's create two new variables, game clock and DT. Game clock will store the amount of time the app has been running, and DT will store the amount of time that passes for each game loop. The time stored in DT is very small, so we'll use floats to store them. We set our game clock to 0 initially. Then we can call on libgdx to provide us with the amount of time it took to execute the full game loop and store it in DT. We can then add this time to our game clock. We'll create a third object called animation that'll be made from our texture regions. We'll create the animation using a frame duration of 0.1, which is the amount of time we want each frame to be displayed before switching to the next frame. We also provide the animation with the texture regions we created. Now that the animation has been created, let's create a new texture region called draw frame that we can load our animation frames into. In the render function, we can load the frame into our draw frame texture region using the animation's getKeyFrame function. We'll provide this function with the game clock and set looping to true so our animation loops over and over again. We can now send this draw frame to the batch and run our program. We can now see our animation in action. Let's smooth the animation out a little more by setting its play mode to ping pong. This will oscillate the frames, first counting up 1 through 4, then counting back down 4 through 1 to provide a smoother animation. And that's some basic libgdx programming. There are a whole host of great graphic tools out there. The typical greats are Adobe Photoshop and Illustrator. While these are great programs, they can often be cost prohibitive to many, particularly if you're just starting out. Luckily, there are now great open source alternatives that are not only free, but are rapidly catching up to their commercial counterparts. An alternative to Photoshop is the free open source GIMP graphics editor. We regularly utilize GIMP to organize, edit, and process our game graphics. GIMP is a very capable drawing program, but particularly excels at applying filters, warping and distortions, and just graphics processing in general. A great thing about GIMP is its ability to expand through the use of Python scripting. We made extensive use of Python scripting to automate and quickly process our sprite sheets. An alternative to Adobe Illustrator is Inkscape. Inkscape is a mature, powerful, and fairly easy to use vector image editor. Despite being free, Inkscape can be used to create wonderfully complex and beautiful graphics, and there's a ton of online resources to get you started. Not only can GIMP and Inkscape produce great results, they are amazing starting places for people just getting into graphic design, as they are free and the skills you learn using these programs are directly transferable to commercial products down the road. And lastly, we would be remiss not to mention Krita. Now, Krita is truly a gem of the open source world. It is an exceptionally powerful professional-grade painting program that is free and available to anyone. In fact, Krita often surpasses its commercial counterparts in many ways. Where Photoshop is an image editor with drawing and painting capabilities, Krita was designed with drawing in mind from the ground up. Krita comes with a wonderful set of brushes and coloring tools and can truly produce incredible drawings. We utilize Krita extensively in the creation of our game art. Audio production. Now this is our bread and butter. In many ways, we started with music and made the leap to game programming. Now, unfortunately, audio production is probably the most difficult to do without spending money. The free and open source digital audio workstations available are just not as developed as their commercial counterparts. However, many programs have demos that will allow you to use them and learn prior to purchasing them. These include Reaper, FL Studio, and Ableton Live. Audio production is one place where Mac actually does shine quite well. GarageBand is freely available to anyone with a Mac and comes with a good set of introductory instruments at no cost. Despite being free, GarageBand can actually be used to yield some incredible results. Many of the me-in-a-box music demos were initially created in GarageBand. And of course, Apple's Logic Pro X offers a full audio production environment, complete with built-in instruments, effects, recording, sequencing, and mastering tools at an extremely affordable price. Also, when making music, the instruments available to you are very important. Typically, they can be downloaded as virtual studio plugins, but are often sold as commercial products. Luckily, there are actually many high-quality, free instrument starter packs that can be used to make great music. Two that come to mind are Native Instruments Complete Start and Spitfire Audio Labs, which offer a wonderful set of sounds and effects for no cost. And let's briefly talk about our collaborative process and how we work collectively to build our apps. We strongly believe that working as a team is important. You learn from each other and can achieve better results working together. Crazy as this sounds, our collaborative process is steeped in the openness of the hip-hop freestyle culture. Brainstorming sessions are creative activities dedicated to inventing new concepts and ideas. For us, it is a judgment-free zone where we actively listen to each other. And listening to each other is key. Suspending our ideas and opinions to allow others to contribute is not always easy, but when done, can dramatically improve our results. We truly believe that everyone has something valuable to say and contribute. In the words of James Weldon Johnson, aspire to lift every voice. Nevertheless, we all specialize in specific types of tasks and we divide our work accordingly. We still create open space for debate, space where we can contribute ideas to one another's assigned work. We are all accountable to each other and provide constructive feedback on our respective works. Sometimes it's hard to receive criticism, and we acknowledge that it can be an alienating experience. And it's normal to have disagreements. But by having the mechanisms for conflict resolution baked into our team culture, we have been able to make points of difference an asset and not a weakness. And finally, I just want to give a little more insight into who we are and where we come from. We started as two kids growing up in Toronto's West End, one from Trethwest Drive and the other from Weston Road. We truly love this part of Toronto with its rich Afro-Caribbean influences and working-class do-it-yourself culture. Trethwest is a representation of this and a representation of where we're from and where we're ultimately going. We are proud to be where we're from and see ourselves as one of its many ambassadors. And that's the point of this video. We aim to show you tools that are easily accessible to everyone and give you a taste of how we work with those tools and encourage you to work in teams to produce real games and apps. And hopefully, through our journey, we can inspire you to start yours.